In this tutorial, we're going to solve a question on the velocity time graph for a skydiver that we explained in the previous tutorial. Question 11 in the book. The question says, look at the velocity time graph for a free fall parachutist shown below. So we have this graph, we have the time t on the x-axis and the velocity on the y-axis, and we have these specific points. What we have to do is state and explain the direction and relative size of the unbalanced force acting on the parachutist at each of the points from A to G, labeled on the graph. So let's start with the first point, point A. Velocity is 0 at this point, so a resistance is 0, and the unbalanced force is downwards. And it is due to the gravity or the weight of the parachutist. At B, as the velocity of the parachutist increases, so does the size of the upward air resistance force. So the unbalanced downwards force is smaller. Next we have point C. Here the velocity of the parachutist has increased to the point where the upward air resistance force is exactly the same as the downward force of gravity on the parachutist. The unbalanced force is 0 and the parachutist has reached a terminal velocity. Let's move on to point D. Here the parachutist has opened her parachute at this time. This greatly increases the upward air resistance force, so the unbalanced force on the parachutist is now upwards. So the parachutist's velocity decreases. We have at point F, as the parachutist slows down, the upward air resistance force due to the parachute decreases. This means that the unbalanced upward force is smaller, so the rate of deceleration of the parachutist decreases. Finally, point G. The parachutist has slowed to a velocity at which the upward acting resistance is once again equal to the downward acting force of gravity. The unbalanced force is again 0, but note that the effect of opening the parachute is to make the new terminal velocity lower.